So we are beginning a new unit, Unit 3, and we are going to be talking about absolute value in this unit. I know that's not a new concept for you. So we're going to start. Make sure, as always, you're writing your last name and your first name, not my last name and first name, your last name and first name. And then make sure you're writing down the essential question, the I can statement. Remember, that's part of our notes grade. So our essential question is, what are the features of the graph of an absolute value function? And then your I can statements are, I can graph an absolute value function, and I can translate an absolute value function and write its new equation. So let's review what absolute value is. Again, this should not be a new concept. So absolute value, written as, and this is kind of got an X with these bars around it, represents the distance between X and any number on the number line. As a distance, absolute value is always non-negative. So when we're talking about it in terms of distance, it's always non-negative, which means it's positive. For every point on the number line except 0, there is another point on the opposite side of 0 that is the same distance from 0. So for example, both 5 and -5 are 5 units away from 0. So whether I go this to the left or to the right, they're both 5 units away. Thus, the absolute value of 5 and the absolute value of -5 equals 5, and the absolute value of 5 equals 5. So the absolute value function, the absolute value of x, can be defined piecewise as when we just have x greater than or equal to 0 and negative x less than or equal to 0. So you can write it as a piecewise, which those are just the lines y equals x and y equals negative x, if I was thinking about it in terms of what I already know. When x is non-negative, the function simply returns a number. When x is negative, the function returns the opposite of x. The absolute value function, absolute value of x, can be defined piecewise as, oh, apparently I typed that twice. You could just cross that out. So we're supposed to complete the input and output table for x. So we're going to start by plugging in negative x, which we know is less than 0, so it's going to go into the bottom branch, which means I would have the negative from here times -8, which is going to be 8. And then I've got the -4 is again going to go into the bottom branch because it fits this domain here. So it's going to be negative from the problem times -4, which is going to be +4. I'm putting in a 0, but that's going to go into my top branch because that's where the branch is equal to 0. So I put 0 in for x, I get a 0. I'm going to put in a 4. When I put 4 in for x, again, it's going to be in the top branch. I simply get a 4. When I put 8 in for x, again, top branch, I simply get an 8. So now what we're going to do is we're going to take these points and we're going to plot them on this graph. So we're going to go out -8. Notice the graph is scaled by 2's and up 8. We're going to go out -4 and up 4. We're going to go out 0 and up 0. We're going to go out 4 and up 4. We're going to go out 8 and up 8. And then we're going to draw a graph. Notice, absolute value, it makes a V, just like the V for value. Okay. So now examine your graph of f of x equals the absolute value of x and complete the following statements about the function. The absolute value of x is symmetric about the y-axis, right? Because I could fold on that line, and therefore is an even function. Okay, so an even function is symmetric about the y-axis. That's one way to show it, and then we'll show the other way here in reflect 1. The domain of the f of x equals the absolute value of x. Okay, so domain is the x values. As I march this way, it looks like I'm going all the way to -infinity. And then as I march this way, it looks like I'm going all the way to +infinity. So we're going to put parentheses. And then range starts at the lowest y value, which looks like a 0, but I'm going to use brackets because it's equal to. And then the highest, because of those arrows, is going to be +infinity, and it's going to be open. All right, this last little reflection piece here, it says use the definition of absolute value of a function to show that f of x equals the absolute value of x is an even function. Well, So there were two different types of functions. There's even and odd. When you have an even function and you substitute negative x into it, you get x back, or you get the original function back. When it shouldn't be x, it should be the original function equals the original function. When you are odd and you substitute negative x, and you get the negative of the original function. So let's try that with the absolute value of x. So I'm going to substitute in negative x. The absolute value of negative x happens to be x, or just the absolute value of x, which is basically the original function. So that's showing that that is therefore it is even.